Good morning, sixth grade. Today we're going to look at Chapter 2, Lesson 1, Studying Geography. So what I'm going to do is I'm going to let the textbook read this to you, and I will chime in where needed. You will also have questions embedded into your lesson here so that whenever a question pops up, you know to answer it and then continue on with your lesson. So let's get started.
Lesson 1. Studying Geography. It matters because geography helps us understand our place in the world. Displaying the Earth's surface. Guiding question. What methods do geographers use to show the Earth's surface? Hearing reports from explorers who had sailed the oceans, geographers realized the Earth was not flat. A new model for the Earth had to be found. A globe, a spherical scale model of the planet, became the most accurate way to show the Earth. A globe of the Earth best shows the sizes of continents and the shapes of land masses and bodies of water. Globes also show true distance and direction. Globes have their limitations. A globe is not as easy to carry as a map. Maps are flat drawings of all or part of the Earth's surface. Maps can show small areas in great detail. Maps can show many things: political borders, population densities, or even voting results. Plus, maps can be folded and carried in a pocket or placed in a car. Maps, however, cannot show true size, shape, distance, and direction at the same time. The reason for this is they are flat drawings of a round object, the Earth. Globes and maps have some features in common. Both are marked with imaginary lines that geographers use to locate places on Earth's surface. These lines divide the Earth into halves called hemispheres.
So I'm going to go ahead and show the video as well to show how maps contain different kinds of information.
This is the map that generations of school kids have grown up with. It's the famous Mercator projection. But Peter shocked the world when he announced that this map was quite simply wrong. He pointed out that Mercator was distorting the size of countries in an attempt to retain their shape. As a result, Europe looks far more prominent, whereas the developing countries are being downplayed. If we look at Africa and Greenland, they look about the same size. But Africa is actually 14 times bigger. Peters condemned this map as being imperialist and racist. Peters was no cartographer, but he thought he had the solution. Taking account of the relative size of each country, he came up with a new formula for representing the globe on a map, and he called it the Peters projection. Peters claimed his map showed the true size of countries for the first time ever. He dramatically reduced the size of Europe, whilst expanding the size of Africa, elongating South America. And it's still something of a shock to look at this map and see how large these two continents loom on the Peters projection. Peters regarded himself as a champion of what he called the non-white peoples, and he saw this map as part of a wider project to right the wrongs that he saw as being perpetrated against those people living in the developing world. Arno Peters invited nearly 300 members of the international press to the unveiling of his new world map. The media embraced it with enthusiasm, but professional cartographers were furious at what they saw as the cheek of this outsider. They called the map deceptive, absurd, illogical. They were clearly really annoyed at what they saw as an untrained cartographer trying to map the world, and they accused Peters of making a map that was full of errors. And the Peters projection did become an international mapping phenomenon. Anyone who wanted to display their liberal credentials pulled down their Mercators and proudly replaced them with the Peters projection. It was championed by Oxfam, the United Nations and the Catholic Church. and it sold more than 80 million copies across the world. But the Peters projection did have distortions of its own. Despite all the success and adulation, the critics did have a point. The Peters projection was flawed, and it wasn't even accurate on its own terms. Peters had made some basic miscalculations, which meant that countries like Chad and Nigeria were twice their actual length. Arno Peters was attacking other maps for being biased, yet he was blind to the fact that the Peters projection was just as distorted by his own political assumptions. But the Peters projection did do something quite extraordinary. It finally exploded the myth that maps can ever be 100% accurate, scientific, objective representations of the world. It showed that maps always have social and political agendas. Arno Peters not only transformed the way we look at the world, he also changed the way we look at maps.
There is no such thing as a neutral map, and you're kidding yourself if you think you're a neutral cartographer. Hemispheres. To find a place on the Earth, geographers use a system of imaginary lines that crisscross the globe. The equator is one of these lines. It circles the middle of the Earth like a belt. It divides the Earth into half spheres or hemispheres. Everything north of the equator is in the northern hemisphere. Everything south of the equator is in the southern hemisphere. In which of these hemispheres do you live? Another imaginary line divides the Earth into eastern and western hemispheres. This line is called the prime meridian. Generally, the area east of the prime meridian is in the eastern hemisphere. Everything west of the prime meridian is in the western hemisphere. Finding places on the Earth. The equator and prime meridian are two of the lines on maps and globes that help you find places on the Earth. All the lines together are called latitude and longitude. Latitude and longitude lines cross one another, forming a pattern called a grid system. Lines of latitude circle the Earth parallel to the equator. They measure distance north or south of the equator in degrees. The equator is at 0 degrees, 0 degrees latitude, while the North Pole is at a latitude of 90 degrees north, 90 degrees north. Lines of longitude circle the Earth from pole to pole. These lines measure distances east or west of the prime meridian, which is at 0 degrees longitude. The grid system formed by lines of latitude and longitude makes it possible to find the absolute location of a place. This is the exact spot where a line of latitude crosses a line of longitude. An absolute location is written in special symbols called degrees and minutes, points between degrees. For example, the Empire State Building in New York City is located at a latitude of 40 degrees, 44 minutes north and a longitude of 73 degrees, 59 minutes west. 40 degrees, 44 minutes north, and 73 degrees, 59 minutes west.
All right, so this should sound somewhat familiar from the videos that we've watched. We did an Edpuzzle on latitude, longitude, and then we just did a vocabulary on latitude and longitude. So just remembering that the latitude lines are parallel to the equator, so they go across the Earth like this, and they're measuring distance north or south of the equator, and then the longitude are up and down, okay, and these lines measure distance east or west of the prime meridian.
From globes to maps. When the curves of a globe become straight lines on a map, the size, shape, distance, or area can change. Imagine taking an orange peel and trying to flatten it on a table. You would either have to cut it or distort or stretch parts of it. Mapmakers face a similar problem in showing the surface of the Earth on a map. Using mathematics, they have created different types of map projections, or ways of showing the Earth on a flat sheet of paper. Each kind of projection shows the Earth's surface in a slightly different way.
So here's one example of trying to take that round Earth, okay, and flattening it out to try to keep the proportions as clear as possible there.
Flattening out the planet. When you take an image of the Earth and flatten it, big gaps open up. To fill in the gaps, map makers stretch parts of the Earth. They show either the correct shapes of places or their correct sizes. It is impossible to show both. As a result, map makers use different map projections depending on their goals. Map projections. Take another look at the flattened orange peel. You might see something that looks like a map based on Good's interrupted equal area projection. A map made using this projection shows continents close to their true shapes and sizes. This projection is helpful for comparing land areas among continents. The map on the top right was made using the Mercator projection. It shows true direction and land shapes fairly accurately. However, it does not show correct size or distance. Areas located far from the equator are distorted on this projection. Alaska, for example, appears much larger on the Mercator map than it does on a globe. A map using the Robinson projection is less distorted. Land on the western and eastern sides of the Robinson map appears much as it does on a globe. Areas near the north and south poles are distorted the most on this projection. The Winkel triple projection gives a good overall view of the continent's shapes and sizes. You can see that land areas in this projection are not as distorted near the poles. Progress check. Analyzing.
Okay, so you can see here there are different types of maps that he's talking about. And if you go back into your social studies textbook, and you can click on some of these resources up here as well to kind of see the different things that they're referring to. For instance, going back, just looking at some of these hemispheres, you can look at those as well.
5 themes and 6 essential elements of geography. Guiding question. How do geographers use the 5 themes and 6 essential elements of geography? To understand how our world is connected, some geographers have broken the study of geography into 5 themes or 6 essential elements. 5 themes of geography. The 5 themes of geography are 1. Location, 2. Place, 3. Human-environment interaction, 4. Movement, and 5. Regions. You will see these themes highlighted in the geography skills questions throughout the book. 6. Essential elements. Recently, geographers have begun to divide the study of geography into 6 essential elements. Understanding these elements will help you build your knowledge of geography. The world in spatial terms. What do geographers do when studying a certain place? They first take a look at where the place is located. Location is a useful starting point. By asking, where is it, you begin to develop an awareness of the world around you. Places and regions. Place has a special meaning in geography. It refers to more than where a place is. It also describes what a place is like. It might describe physical characteristics, such as landforms, climate, and plant or animal life. Or it might describe human characteristics, such as language and way of life. To help organize their study, geographers often group places into regions. Regions are united by one or more common characteristics. Physical systems. When geographers study places and regions, they analyze how physical systems, such as hurricanes, volcanoes, and glaciers, shape the Earth's surface. They also look at the communities of living things. The populations of plants and animals depend upon one another and their surroundings for survival. Human systems. Geographers are interested in human systems. Human systems refer to how people have shaped our world. Geographers look at how borders are decided and why people settle in certain places and not in others. A basic theme in geography is the movement of people, ideas, and goods. Environment and society. How does the relationship between people and their natural surroundings influence the way we live? The theme of human environment interaction investigates this. It also shows how people use the environment and how their actions affect the environment. The uses of geography. Geography helps us understand the relationships among people, places, and environments. Mastering the tools and technology used for studying geography can also help us in our daily lives. Connections to today. GIS, GPS. Technology has changed the way we make maps. Most map makers use software programs called Geographic Information Systems, GIS. This software combines information from satellite images, printed text, and statistics. A global positioning system, GPS, helps people locate places based on data broadcast by satellites.
So that's kind of a good tie-in to see how this all affects us still today. I'm going to stop at this point on this lesson, and then I will continue with another video for tomorrow with the remaining lesson and additional questions to answer. So at this point, have a great day.